Hi, this is Ratan Gupta from Knowledge Varsity. Welcome to today's class on reading 7. Today we'll be covering descriptive statistics in this reading. This is a pre-class content. Hope you will find it useful. Please send me your comment about this class, how I can improve it. Okay. This I am using GoToMeeting and this is very useful for online as well as offline course development. Let's start the class. So in this we'll be covering fundamental concepts about the statistics. Okay. So first and foremost, we will be covering what is population. By definition, population is a universal set. Okay. Let's say that you want to find out the mean height of males in India. Okay. So your population in that case would be the entire male population of India. So that is a population. But the problem in getting data for a population is that you will not be able to measure the height of all the people in India. So what you do is you take out a sample. So sample is a subset of the population. So you find out the sample mean height of the people. So you find out the sample mean height of the people, and from there, uh, through some probability, you will be predicting about the population. But as of now, in reading 7, our idea is to get the description about the population and the sample. So how we describe the population and the sample, we describe using the parameters. So these parameters are descriptive measure of population or the sample. Okay. Now when I am saying about the parameter, that is also called as statistics. So a population statistics is describing some of the properties of the population. Similarly, a sample statistics is a describing something about the sample. Okay, so it is describing about the sample. So in our case, if we let's say get 1,000 males and find out the average height of those 1,000 males. So these 1,000 males average height is describing about the sample average height. Okay, so the process of describing this population or the sample parameter through which we get more insight about this population or the sample is called as descriptive statistics. This is a branch of statistics which deals in describing the data. Okay. There's another branch of statistics which is called as inferential statistics. Here what we are doing is here we will be able to forecast about the population parameter based on the sample data. So here the idea is to forecast from the sample data about the population. So if you would have seen the exit poll that happens in India, through just getting 500 votes, people are able to predict about who will win in that particular constituency. So that is done with some probability. So forecasting is done with certain probability. Okay. Now let's go to measurement scale. So what is a measurement scale? Measurement scale are how we will be measuring the statistical data. So there are 4 measurement scale: nominal scale, ordinal scale, interval scale, and ratio scale. Okay. So nominal scale is the weakest level, whereas ratio scale is the strongest level. In nominal scale, what we do is we just categorize the data, that is we just group the data, but we do not perform any ranking of this. So let's say if you are having a set of companies that you are researching upon, you can categorize those company data in large cap, small cap, etc. So you have just categorized the data, but you are not saying that which is more, that is whose return is more, whether large cap stock return is more or small cap stock return is more. Okay. Another kind of measurement scale is ordinal scale. Here you have done grouping as well as ranking. So you have an order data as well as some rank. So let's say from your stock return, what you have done is like you have found out the top 20% stock and you have assigned 5-star rating to those stock. Again, you have find the next 20% stock and you have assigned 4-star rating to that. Now if I say okay, there is a stock who is rated as 4-star, Will it be better than 5 star or not? Yes, definitely it is better than, it is not better than 5 star stock. In fact, 5 star stock is better performer than a 4 star stock. But here I do not know how much 5 star is better. Okay, I have an idea that it is better, but not by how much. So there is another type of a scale which is interval scale. Here we find out the exact distance or the differences between these two. Okay, now here what we do is like we allocate the various intervals to this, and from there we know that okay, that grouping is done, the ranking is done, and now there is an exact difference between one group and the other. So let's take an example. If we try to measure temperature using our centigrade scale, what we have done is, here we know that 4 degree is hotter than 3 degree, and it is hotter by 1 degree. Okay, so we have grouped, we have ranked, and we also know the exact distance. But the problem in this scale is that we do not have absolute zero. That is, 0 degree centigrade does not mean absence of temperature. In fact, it is minus 273 degrees centigrade, which is absence of temperature. So a further refinement is done in, it is called as ratio scale. Here we have done grouping, ranking, also we have exact distance, but we have here a 20 point. So let's say that I have 10 rupees, you have 20 rupees, you have 2 times more money, so it's a ratio than me. Also, a person having zero money, it does not have any money. So this is the strongest measurement, and in finance we will be using this measurement only. Okay. Now we will go to what is frequency distribution. In school we have done this kind of distribution, wherein like there are some data set is given. So let's say we have a various return data set, and from there what we do is we perform tally and find out how many of this data set fall in this interval, how many of data set fall in this interval, how many fall in this interval. From there we find out, that means that how many are falling is the frequency. So 5 data set fall in this interval, 10 in this, 5 in this. So these are the absolute frequency of that interval. Okay. Now if you see the sum of this is 5, 10, 5. So there are 20 data set in total. So that the number of data set is 20 in total. So 20 data sets are there in total. Okay. So 20 data sets. Now the concept of relative frequency. Relative frequency is how much is one interval frequency relative to the entire data set. So I want to know what is the relative frequency of this. It will be this, the frequency of this interval divided by the total. So this 25% is nothing but 5 by 20. Similarly, we have relative frequency for the other intervals also. Remember that the sum of this relative frequency should come to 100%. Okay. Now we have another measure, cumulative frequency. Cumulative frequency measure what is the frequency up till the largest value in the interval. So this 5 means up till 0% we have 5 values. Okay, that is, now since there is no interval which is lesser than this, so I have 5 values between minus 10 to 0. This will become more clear when we consider this. So I can say that there will be 15 data points whose returns are between minus 10 and 10. Okay, so it encompasses this and this. So cumulative frequency is equal to absolute frequency of this interval plus absolute frequency of the previous interval. Similarly, cumulative frequency of this interval would be this plus this plus this. So that comes to 20. Okay. Similar to relative frequency, we have cumulative relative frequency, that is for that particular distribution, what is the, how much that is constituting of the total. So this particular distribution cumulative is 25, but 0 to 10% since encompasses that also. So we have 75% of the distribution left, and the last interval should have 100% of the cumulative relative frequency. Now how we can represent this diagrammatically? We can represent this diagrammatically using histogram. So this histogram is diagrammatic representations of frequency distribution. So the first interval has 5, then 10, and then again 5. So this represents it. Now we can further enhance on this by taking out the middle value of this interval, by taking the middle value of this interval, and joining these points. By doing that, what I come to is I come across frequency polygon. Okay, so here I am just here the frequency polygon is just joining the midpoint of this. Now after visiting this frequency, let's focus on central tendency, but we will be doing that in a separate video. Thanks for attending this one.